Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley, and this is lesson 2.1 on piecewise functions. It is a supplemental lesson. You'll have to do the supplemental practice work. Okay, students are going to graph some piecewise functions. We're going to talk about what those things are, and we're going to find a piecewise function from a graph, and then we're going to answer some questions involving piecewise functions. So what is a piecewise function? A piecewise function is a function that has different rules that are determined on different points of the domain. So here is an example of a piecewise function that has been graphed. It has three pieces. It has some different intervals along the x-axis. And so the first interval here is from negative so this first interval right here for this first piece is going to be values of x that are less than or equal to -1. The second interval right here is going to be values of x that are between -1 and +1, and this last interval are going to be values of x that are greater than or equal to +1. And just so that we're clear here, I want to make sure this was not intended to be a negative. I was putting another little a little bullet point there. But these are the three intervals that we are talking for this particular, and then we have three different equations for each of these three line pieces, and we'll get into how to find those here very shortly. All right, so to graph a piecewise function, we're going to plot the transition point for the first piece and determine if it's open or closed or open. And then we're going to plot some points in the interval of the first piece, and then we're going to repeat steps 1 and 2 for any remaining pieces. So let's talk a simple example here. And so here is a piecewise function, and it is defined with two pieces. So we have one piece right here, and we have two pieces right there. And this first piece is defined for values of x that are greater than 3. So for this particular one, this top rule, this y equals, and so what this literally means here for piece 1, we're going to use the equation y equals x plus 2 for values of x that are greater than 3. All right, so just like we plotted way back in probably 8th grade when we learned to plot linear equations, we're going to make a table of values x and y, and this is a linear equation. And even though 3 is not in the interval, we're still going to graph it. We're still going to plug it in. We're still going to plug in x equals 3. 3 plus 2 is going to be 5. And so our first point is at 3, 5. But because it's not included at 3, 5, we're going to have an open circle here. And then we can plot any other point that we want that's greater than 3. So let's pick 4 just to keep it simple. And then 4 plus 2 is 6. This is a point on the graph, and it is represented by a point, and it's definitely a point because 4 is included in this. 4 is greater than 3. And so if we were doing this one, we would just connect the dots and we would have a line that goes like this. Now for piece 2, and I'm going to erase this, you may want to put it on a separate sheet of paper here. But for piece 2, this second piece right here, we are going to graph y equals -x plus 4 for values of x that are less than or equal to, that's not very good, or equal to 3. And so again, we're going to plug in, we're going to make ourselves an xy table, and -x plus 4 is a linear function, so we really only need two values, and I'm still going to pick 3. Why? Because 3 is one of those transition points. It is where it transitions from one rule to the other. Now when I plug in 3, I have to make it negative, so -3 plus 4 is 1. And so at this case, in this time, at 3, 1, I'm going to have that point right there. And it is a closed circle because this symbol right here does tell me to include it. And then I can pick any other value for x that is less than 3. I'm going to pick 0 because 0 is clearly less than 3, and because I can cheat and say that since this is a linear equation, negative x plus 4, when x equals 0, we're talking about the y-intercept, so it would be clearly 4. And I can plot that point right there, and then we'll just connect the dots. And that is my elementary example for a piecewise function. Here's one that's a little bit more detailed, and this one has 3 pieces, and I'm not going to go through all of the steps and write out everything that I did in the last one. But this one says that for values of x that are less than or equal to -2, I'm going to use the function y is equal to x minus 1. So for my piece 1, I'm still going to make a table of values here. So I'm going to go x, y, and I do need to pick this -2. So I plug in -2. -2 minus 1 is -3. And so since it's a less than or equal to symbol, I will close that dot there. And I need to pick another value that's less than -2. And so I'm going to pick -3. -3 minus 1 is -4. So -3, -4. And since y equals x minus 1 is a linear equation, I can connect the dots there. And I can put on a little arrow, and I'm done with piece 1. That's good. So now we're going to go to piece 2. And in this case, I'm going to do x, y, and the equation x equals to, or y equals to 4. This is a constant, and since it's a constant, that's going to mean it's a horizontal line, and it's going to be a horizontal line from -2 to +3. But because it's a less than symbol and a less than symbol, I'm going to have open dots. So when x equals -2, I'm going to get 4, and when x equals 3, I'm going to get 4. So at -2, 4, I have an open circle, and at +3, 4, I'm going to have an open circle. And I'm just going to connect the dots there. And then that is done with piece 2. And now I'm going to try piece 3. And for piece 3, I'm going to pick values of x that are 3 or greater. And so we'll go P3, and we'll go x, and we'll go y. And since 3 is the transition point, I'm going to clearly use 3. 3 times -2 is -6, plus 10 is 4. So at 3, 4, 3, 4, notice that has an open circle in it. But in this particular case, since that point is the same point, I am filling it in with this new one. And now I have to pick another value for x that's greater than 3, so I'm going to just pick 4 just to be safe. And then 4 times -2 is -8, plus 10 is +2, so at 4, 2, I'm going to have another point, and I'm going to connect those dots. And so the lesson that we learned from this is that even though in the 2 examples that I've already done, there's a big gap when the intervals change, and here we have a big gap when the intervals change, they don't necessarily have to have a big gap. They could connect each place in the dots. All right, so the final example that we have for this one, for this lesson, is find a piecewise function. And so what we're going to do here is we're going to write the piecewise function for this graph that is given here. And here again, we have an instance where both of these points intersect even when they change. And I clearly have 2 pieces. I have this line right here. So this line here will be my piece 1. And this line here, let me do a better job, piece 1 right here. And this line segment, line array will be piece 2. And so all I got to do is find the equation of these 2 lines. And so my function f of x is going to be equal to, I need 2 pieces. Now the first piece, we've got to fill in an equation for this line. And then we have to fill in an equation for this second line. But let's get the interval down first, because that's fairly easy. This first line goes from negative infinity up to 0. And so for this first piece 1, we're going to say x is less than 0. And then for our second piece, piece 2, we're going to say the values of x that are greater than 0. Now, clearly, we have a point that's filled in at 0, and neither of these include 0. Now, because of the way it's drawn, you could technically put the greater than or less than, greater than or equal to symbol in either of these, but you cannot do it in both. So I'm just going to put it here on this top one. If you left this one blank and did it on the bottom one, that would also be cool, but you can't do it for both, because that would give us two y values for one x value, and that would cause this to no longer be a function. All right, so we want to find the equation of the line for these 2 points right here. And so what I'm going to do is I'm going to find the slope for piece 1. And so we'll go, the slope m is y2 minus y1, so negative 1 minus 1 over negative 1 minus negative 2. And that will give me, let's see here, I'll have negative 2 over positive 1, so I have a slope of negative 2, and that makes sense because if you look at it, down 1 to right 1, that's my slope of negative 2. And so if I go y equals mx plus b, I already know what the slope is. It's negative 2x, and we could plug in, well, we've already plugged in points, and we've already found y-intercepts. But if we notice, this has already given me the y-intercept. It's right here. So I'm just going to cheat and go negative 3 there and say that my first piece is negative 2x minus 3. And so for my piece 2 slope, I'm going to use these 2 points here. I'm going to use negative 3, 0, and or excuse me, I said that backwards. 0, negative 3, and 3, 2. So I'm going to change my y, so negative 3 minus negative 2 over, it'll be 0 minus 3, and that will give me, let's see here, did I do that right? Change in y is negative 3 minus negative 2 will give me negative 1 over negative 3. That'll give me a positive 1/3, and positive 1/3 makes sense because up 1, right 1, 2, 3 gives me that point there. And again, I have a y-intercept at negative 3, so my slope-intercept form will be y equals positive 1/3 x minus 3, and that is what I'm going to put for that piece of my piecewise function, and that is my final answer. Well, that's all I got for today here, folks. I hope you have a good day. Here is my Marvel fun fact of the day. Chris Pratt lost 60 pounds to get in shape for his role of Star-Lord in Guardians of the Galaxy. That's all I got. Have a good day. Short one. Bye.